So if you don't mind, we will go ahead with some good questions, and in no particular order, but because this is the shortest one, could COVID mutate around a vaccine?
Yes. Well, it depends on where the vaccine is. If the vaccine's to that end part, that part's mutating pretty fast. If the vaccine is to the stem part, which I showed you doesn't change much, it doesn't mutate much, then the vaccine would probably last longer. But most of the time, usually it goes, they make the vaccines happen to go out to the part they can reach the easiest, which is the stem, out the end of the stem.
Okay. And could you just remind us, I know you talked about this, but which groups are developing vaccines that address the stem, which would therefore last longer?
Well, probably that's the RNA ones.
Okay.
Remember, I had the DNA and the RNA. They just make the DNA or RNA that will make this. They can make the stem, so that can control what you make on the surface of your cells to produce the antibodies.
Okay.
So now, I would bet on those being the RNA vaccines or the DNA vaccines. I would bet they work better. That would be my guess.
Fascinating. And a climate-related question. So people were speculating way back in the spring that as the summer came on, due to people spending more time outside, that the virus might actually decrease in effectiveness. But in fact, the opposite has happened. It's taken over. So do you think there's a seasonal dependence of coronavirus like there is for the regular seasonal flu?
Well, I think the difference here is that this virus is really a tough virus compared with the flu. And I think the reason it's apparently very infectious, and it transmits very well. And so it didn't matter that there was this warmer weather, it doesn't seem to affect this virus. UV will inactivate this virus, and they think, of course, there's more UV light in the summertime, but this virus really is transmitted so well by the vapor, the water vapor coming out of your mouth, that I think that's why it did so well over the summer, and it's going to do even better this fall.
Mm-hmm. Well, that relates to something that you alluded to at the very beginning. We, of course, are a university. We have thousands of students. And I was just reading an article today on how when we are young, our brains don't process risk the same way as they do when we're adults. In other words, we're more prone to both social behavior and to risky behavior. So young people tend to think that they won't suffer the consequences. And is there any validity to this assumption? You talked a little bit about the fact that football players are experiencing inflammation around their hearts. Could you talk a little bit more about young people and coronavirus?
Well, of course, as I said, those football players are really healthy, well-developed individuals, and they weren't protected. And what we know is that you form these microclots, and the microclots can cause problems that last later. In fact, this virus is weird because it causes what's called a net formation. That's where DNA and protein get together to form sort of they surround the virus. But in this case, these seem to form bigger clusters. And this can cause things like COVID toes, COVID fingers, where people are having trouble with their fingers and their toes. And a lot of little kids also have this problem. And there are children that are dying of this virus. So let's not say they're pretty tough, and kids seem to have a good immune system that lets them do this, but there are children that are dying from this virus. So I forget how many have died so far, but it's a fairly good number. And of course, the adults, we're approaching 270,000 people now. Mm-hmm. So young people, of course, the problem with young people is they may go home to visit their parents or their grandparents, and they may have the virus and not even know it. And that's even worse. So there was a lot of young people. There was this young boy, for instance, that went to one of these COVID parties, and he died from it. And he was talking as he was dying that it was obviously a big mistake that he made to think that he was immune from this stuff, and you're not.
Mm-hmm. So going back a little bit in history, we have a question from Gary. He says he'd like to understand how treatments developed for retroviruses. So how HIV might impact any possible treatments to address COVID transmission, and any control mechanisms that might be relevant to viral load in evaluating risk factors for transmission. So any parallels between past virus research and COVID?
Well, we don't know the viral load that's required. We're guessing it's in the thousands that you have to get a pretty good little blast of viruses. But you figure every time you breathe out, you're breathing out. They say you're breathing out enough to infect 1,000 people. Fortunately, there's not 1,000 people crowded around you. But HIV is, of course, a totally different situation. That's not transmitted by breathing the virus out. That's a sexual transmission. And it must be that particular virus requires a totally different way to infect you. Here, of course, you've got a virus that combined to right in your throat. You have all these blood vessels and everything in your throat, and you've got the ACE2 protein right there. The protein the AIDS virus uses is a totally different protein. That's a protein that's found on T cells. And so it's a whole different picture that it has to bind to this protein, the CD4 protein on a T cell, and then that's the way it gets inside the T cell, and the T cell makes all those virus. And the virus doesn't really kill you. What kills you is the fact that you lose all your T cells, and you die of all kinds of other diseases. That's what AIDS is called. That's why it's HIV AIDS. It's really, the virus in that case kills you by a different mechanism. So in this case, of course, primarily the problem with this virus is gets into your lungs get very congested. This virus turns out to make an incredible immune response, which they call cytokine storm. Your immune system goes nuts, and you're starting to that's what causes these clots to form. So it's a different killing mechanism by these two different viruses.
That makes sense. All right, we have a couple more questions about the vaccines. So for example, we know now, right, that if you get the disease, your immunity only lasts a few months. Is that right?
Well, the antibodies seem to only last a few months. You may still have those memory B cells that will make more antibody when a new virus infects you.
Okay. So would a vaccine potentially offer a shorter or a longer immunity period compared to actually getting the disease and recovering?
Well, it's long enough to get rid of the virus.
Oh, okay.
And that's all that matters. The fact that hopefully the memory B cells are still around for a couple of years after that, they would protect you for a longer period of time.
That makes sense. Okay. Now, a question about all the different vaccines that people are developing. Do you foresee one vaccine sort of winning the race and everybody gets that one? Or do you foresee a couple of different ones being available, and would they be available where people could choose between them, or depending on where you lived, you'd have access to this one or that one?
Well, of course, we're going to have to look at the side effects from the different viruses, or from the different vaccines. And that will help people make a decision, or help the government make the decision. The FDA is ultimately going to be the one who has to approve the vaccine. And so they're going to look at the side effects. They're going to look at the efficiency, how effective this vaccine is. Like I said, some years, as you know, the flu vaccine doesn't work very well. Some years it does. So they'll be looking at efficiency. They'll be looking at side effects. And then they'll try to make a decision. It could be that more than one will be approved. My bet, as I said earlier, was on the RNA or DNA vaccines. However, they may have some interesting side effects. So we haven't really experienced too much with those kinds of vaccines yet. So that will be, well, time will tell.
Well, okay, so when you say interesting side effects, what do you mean by that?
Well, one possibility, of course, is that the RNA virus, for instance, the vaccine, that RNA vaccine is going to be inserted into your cell. It's going to teach your cell how to make spike protein, or the fragment. So that cell in your body now will have spike protein on its surface. Well, you're going to have antibodies against that spike protein, so it's going to attack that cell as well with the white cell, with the help of the white cells. So who knows what's going to happen from those vaccines.
Mm-hmm. As a
So
climate,
although I'm betting on that,
uh-huh.
I don't think I'd want to be in the clinical trial to test that.
We have interesting things in climate science too, and I think it's the same meaning of the word. So if anybody here is signing up for a clinical trial, you might want to reconsider. Okay, we have a couple of questions of things that we hear other people say a lot. So, for example, some people say, well, this doctor over here said that you're only contagious if you have symptoms. What would you say to that?
That's not true. It's just not true. We know that's not true.
Yes. Okay, now,
we have data.
I have even had a few people who I know claiming that this virus was manufactured in a lab. And so to what extent is it possible to manufacture, not this one, we know this one was not, but to what extent is it actually possible to manufacture killer viruses in a lab and distribute them?
Sadly, that is possible.
Okay.
We have a lot of great tools now that let us do a lot of things. So far, that has not happened. Most scientists are very reputable people.
But there's a lot of us, and you can sometimes find one who isn't. Yes.
Right.
Is there much hope for producing antiviral drugs in general in addition to vaccines?
Well, I'm betting on it, but we'll see. Mm-hmm. I think to me, it looks pretty straightforward. As I said, it's not a difficult problem, I don't think, to make something that's going to target the virus specifically and knock out that element and leave everything else alone. So we'll know pretty soon.
Mm-hmm. Interesting. So in addition to getting tested for COVID itself, you can also get tested for the antibodies, which means that you've already had it, right?
Yes.
Okay. So with the antibody tests that they're doing in the United States right now, are they testing for both of the mutations that we have in the US or only one of them?
I don't know. Good question. I do not know.
That one was from one of your colleagues, a medical doctor.
They may know. I don't know.
Yeah, that's kind of concerning, isn't it? Because
well, they're not that different. I'm betting that the antibodies work the same in their tests for both. Okay. That would be my guess.
That's interesting.
But I do not know for sure. It would be a very specific antibody test if it only picked up one. Let's put it that way.
Okay. So speaking again of mutations, what are the chances that this particular coronavirus would go back into an animal reservoir, mutate, and come back to humans, as opposed to just a new coronavirus eventually coming to humans, which might not be as bad?
That's perfectly possible.
Oh, if you had to guess what animal reservoir it would go into, would it be a domestic animal or domesticated or wild?
Well, that's what we have to worry about.
Cats or dogs?
Well, one came from a civet cat is not really a cat.
Right.
It lives in a tree and it's their properties, but it's certainly possible. There are many different animals that can be reservoirs.
Uh-huh. All right, we have a bit, so I have to say, keep the questions coming. I think we have already smashed the record for the most questions of any Science by the Glass, and they're still coming. So we're going to take a few more. So if you still have a question, go ahead and put it in. I think we have time to take a few more. But I'm going to ask a technical question that got asked way back at the beginning, which is, you were talking about nasal delivery of a peptide that you were making. Are there any binding issues with nasal or esophageal tissue with that peptide?
Binding issue, I'm sorry, I missed that part.
Are there any binding specificity issues with the peptide?
Oh, yes. The peptide is very specific. It binds only to that little part of the spike protein.
Oh, okay.
And so it will not bind to any other protein.
Okay. Fascinating. That's so customized.
Actually, it's interesting that I had a slide for this, but I took it out. That most of the virus is actually up in your nose, in your nasal part, and not as much in the lungs. It turns out that there's more of the ACE2 protein in that part of your system. And so there's not as much infection in the lung, but that's where all the problems come from. So that's why it's very important for us to hopefully knock it out in the nasal passages.
So that's why they're saying in some cases that inhalers work or some type of treatment because it addresses your nasal passages.
Mm-hmm.
Interesting. Okay. So in addition to developing antibodies, are there any approaches to increase our T cell immunity?
Well, it turns out, it's interesting, that some people have more T cells that will attack this virus.
Mhm.
About a third of the population does, and we don't know why. It could be some other virus happened to activate those T cells and they cross-react. We don't know. We do know that people that have the tuberculosis vaccine, I actually had a slide for this too, but I took it out because we didn't have that much time. If you get the tuberculosis vaccine, which we don't give in this country and Canada and Italy do not give that vaccine. What we do is we wait until if you got tuberculosis, we could treat it with drugs. The drugs are expensive, so actually the poorer countries give the vaccine because they don't want to have to deal with treating the problem. And so it turns out a person that's had that vaccine, which activates T cells and other cells, they have a 10 times better chance of survival. And so the two of the countries that have the biggest problems, us and Italy, didn't give that vaccine. The European countries gave it for quite a while, so a lot of their adults have had that vaccine, but they quit a while back because they figured they could just give the antibiotics to protect.
Right. That's so interesting because I'm Canadian, and so I came to the US as an international student, and I had to get a TB test in order to be accepted at the university in the US.
Uh-huh.
All right, so we have a couple of last questions here, which are very practical. The first question relates to testing. So as we know, the traditional test is they stick that thing way up your nose, they send it to a lab in Austin, you get the results a week later, where if you haven't quarantined yourself, you've been running around infecting people. But we know that there's this rapid result test, right, that they just use saliva for. And how long before we can access that here in Lubbock? And I know they're already using it in Texas. And I read a Houston Chronicle story. I'm paraphrasing the question a bit here, adding my own. I read a Houston Chronicle story last week saying that the state of Texas is not including the rapid results tests in its new counts of cases every day. So the new counts for Texas are massively underestimated because they're not including the rapid test.
Mm-hmm. Well, here's what I know personally, in fact. I had a cold a few weeks back. And of course I panicked because of cold, I'm getting all this congestion and I'm coughing. And so it turns out right here in Lubbock, you can get a very rapid test. They put a little swab up your nose, and then within 15 minutes, they can tell you with about 13% accuracy whether you have the virus or not. Now, if it's positive, you have the virus. If you have a negative, there's a 13% chance that it's a false negative. Now, with a 13% chance, as you know, you could have it again. Mm-hmm. You could take the test again, and then we've dropped that way down to maybe 13% of 13%. So if you wanted, and that's being done right now in clinics here in Lubbock. So that's what I would do, because have it twice if you want. And that way you've really lowered your chances of having a false negative. And it's only 15 minutes.
Oh, okay. So what you're saying is if you take this test and it's positive, you definitely have it. But if it's negative, there's a 13% chance that you actually have it, even though the test was negative. So
That's
then
correct.
you could take it again, and that would reduce the chance much more.
And the way they know that was, UMC was doing this. Uh-huh. And UMC was comparing it. They would do both. They would do this rapid test, and they would do the PCR test, where they actually have to they have to put it through the PCR machine there, and that takes a long time. So they did both, and they saw that if it's positive, you have the virus. And it agreed with the PCR, but there was this 13% chance. Even PCR sometimes is wrong, but it's much less.
Huh. So we were actually doing those tests right here in Lubbock.
Yep.
That's so interesting. Okay, 2 final questions, and these are extremely practical questions, I think, that apply to almost everybody listening. Number 1 is, when a vaccine is released for the public, how soon would you recommend getting it? Right away, wait a little bit, or what?
Well, if it's FDA approved, that means they've looked at the any kinds of side effects, and that it has a very good, and they usually tell you up front what its efficiency is, because of if it's gone through phase 3 trials, they'll know. What we don't know yet is, of course, this government's in a big rush to get this thing out. Now, if you're in a real rush, one of the things they're speculating is, will they actually give people the vaccine and then give them the virus to test it? Now, that's unethical at the moment. Are they going to waive ethics? Of course, with this government, I'm not so sure about ethics anymore. So I don't know, but that's what they have to do. That's the reason the phase 3 trial has to be so many people, is because you give maybe several thousand people this vaccine, and then you wait and you see how many get the virus versus the same number of people otherwise. So that takes time,
Right.
and it's all statistical. But it's unethical, I think, to give people the virus to see if it protects them. However, those kinds of things were done in the past, like with yellow fever and things like that. We actually infected soldiers. They volunteered. It was like a war. And we say, okay, you're going to risk your life here to see if this vaccine works. Will that happen? I don't know.
Do you think they're doing that in other countries?
I don't know. I don't know.
Yeah, that's a challenge.
I think it might happen in Russia.
Yeah. Okay, and so last question, for those of us who start teaching next week, and of course the headlines a couple of days ago were that UNC Chapel Hill closed down and went 100% online after they had COVID outbreaks in their dorms. I read a headline this afternoon, just before I clicked the Zoom link, saying that Notre Dame just went 100% online after having an outbreak. So for those of us who start teaching next week, is there anything above and beyond the recommendations that the university has already sent out to us that you would recommend to keep ourselves and our students safe?
Well,
besides going online.
I want to be online, but well, the reason we went to where we had the face-to-face is because parents were complaining because they were renting these apartments in Lubbock, and they're paying us rent, and the kids were staying in the apartment. We're going to be staying in the apartment because we were going to go 100% online initially, and then they backtracked from that. I would say I wouldn't want very many students in the classroom, and I would be constantly telling everyone they had to have their masks on the whole time, and I would go to all the extremes I could to protect against this, because it's the teachers that are the real worry, because the students probably, again, we know their infection rate is much lower, but gee, I think it's irresponsible right now. I really do.
Well, and some schools are taking temperature, of course, every day before they let the students in. But of course, having a temperature is no guarantee, or not having a temperature is no guarantee, right?
A lot of people do not have, I think it's only like 40% have an increase in temperature.
40%. I was wondering about that.
Of the people that have the virus.
Okay. All right. So
that's not very good.
No, it isn't. So you have a 60% chance of not picking it up then. That's not good at all. All right, we have a couple, like 1 minute left, and we're going to give our last question to Mackenzie. She wants to ask you her question on camera. Go ahead, Mackenzie, turn on your camera and ask your question, and then we'll wrap up.
Hi. So on behalf of all the students who were going to be in classes, I thought I'd speak for all of them and say, is there a way that...
Oops, I lost your voice.
You're cutting out there.
Can you hear me now?
Yes.
Yeah.
Okay, I have a professor who is requiring attendance in person. Is there a way that student rights to not go?
Well, I think there should be. I think that's irresponsible. I really do. I think that's one of these people that think that they can just get away with anything and that the virus really isn't a problem. And these 170,000 people that have died from it are some sort of fictitious thing. I think it's totally irresponsible myself. Mm. And I think students should protest and be allowed to not have to be there in person. Mm. That's my feeling.
I've written a letter and asked, and I pretty much got the same answer. I was just wondering if there had been any updates on your end about that.
No, but I think things are going to change pretty soon.
Yeah, I mean, so we have a comment here. So Michigan State already decided to go online only too. And I feel like we're going to see university after university just making this transition as they have outbreaks this fall. Well, I just want to share one last comment from Christiane, and she said, this was so informative. Maybe we need a second episode with you, Dr. Reid. So, thank you so much. This has been incredible. For everybody who's listening, this has been recorded. It will be posted on our Facebook page. It will be posted on our YouTube channel. You will be able to share this with people so they can watch it again. Honestly, I feel like I'm going to be watching this again myself just because I learned so much. I want to make sure I digest it fully. We have a second request for another one. So maybe we might ask you for an update later in the semester once we know more that's happening and you have more to share. So we will be posting this definitely on social media. And thank you so much for joining us.
Well, my pleasure.